forest is so important and relevant because it is until now underinsured, mostly, and nevertheless you saw the big events we had not only in Europe and the Mediterranean, but now this year also in Australia and in other areas. We even had in Scandinavia big forest fires, not expected, and really something new. And it is of course very much connected to climate change because higher temperatures and especially drier climate is the basis for additional forest fires worldwide, possibly.
If we look at the statistics, major forest fires are indeed rare. Forest fires themselves are very common. Hundreds occur every year, everywhere, but 99% of them are very small. The major fires are becoming more frequent with rising global temperatures, and therefore of a concern not just to the forestry companies, but also local communities, schools, installations, hospitals, and the fauna and flora that are really impacted by wildfires, such as we've seen in California or Australia.
So when we talked with our partners from insurance companies, we understood that there was a gap to bridge between the existing tools, the existing operational tools, and on the other side, scientific models that really relies on meteorological factors, because meteorology is very important for the propagation of a fire. And so there was a gap to bridge, and that's why we decided to build the Risk FP tool. So this means risk fire propagation. And it's a tool based on a huge weather database. So it includes a historical database for the past 30 years. So we can make simulation for any event during the past 30 years because we have the meteorological data. And once the insurers have this information, they can select the specific days and make what we call the realistic disaster scenario. This means that they can make some scenarios of propagation of fire.
Now, one of the biggest problems in insuring forestry against fire or wind is knowing how bad can it be. And until you have these events, you have no idea. And they can run the fire and see how bad it can be without destroying a single hectare. And this is why I was so excited about it, because if insurers can put a number or a value on the worst case based on hourly weather data for the last 20 years, then they can price more accurately. If we can't do that, then we guess. So that's why we need that knowledge.
The objective was to design Risk FP as a web-based tool for support for decision making. So it has to be simple, easy to use, and a friendly tool. So we decided to design it with just a few functionalities. The first one is to plot the fire propagation, which is called the realistic disaster scenarios. Those realistic disaster scenarios are based on the risk map, which is the map showing the easiness for a fire to propagate. And the two other functionalities are the seasonal forecast and climate forecast to give frequency of possible days with extreme event of fires.
The next steps with Risk FP, now that we understand it and we can explain it to our colleagues and to our client companies, is to see if we can make more use of this across the insurance sector. New tools give credibility to the underwriting. When you're depending on some old-timers that are just pricing forests based on their experience and averaging a few old figures, that is not the way insurance works anymore. Insurance is all about modelling losses and deriving from those models risk pricing at different levels of limits and tree types and so on. So forestry now has the tools with things like Risk FP to bring discipline to the underwriting of forestry, which wasn't available 5-6 years ago.